Welcome to part 2 of compounding creams. In this video, we are going to be looking at the preparation of creams. Now, when we are preparing creams, we need to appreciate that, as I said before, there's an oil phase and an aqueous phase. The aqueous phase would be carrying or dissolving all your water-soluble ingredients. The oil phase or the lipid phase would be dissolving or carrying your oil-soluble ingredients. It is important for you to look up the characteristics, the physical-chemical properties of all ingredients in your recipe, right? For you to appreciate the specific roles of your ingredients. Now, when compounding creams, they are solid ingredients, those sticky butters, your waxes, right, that you need to melt. And when you melt it, you'd be guided by the melting point so you don't compromise the ingredients. Then we have the emulsifying agent, which is normally dissolved, for example, in your aqueous phase, because you want to prepare the water phase so that when it meets the oil phase, there is a nice emulsion that results. For example, you may have non-ionic surfactants, detergents, and soaps. These are examples of emulsifying agents you'd find in cream formulations. Now, it's important to look at the recipe and separate what is the oil phase from the aqueous phase. Both phases are heated to a temperature above the melting point of the ingredient with the highest melting point. So I've placed an example here for you. For example, if the formulation has beeswax, which is a solid ingredient, waxy substance, if you look in the Martindale Pharmacopoeia, you'd see a melting range, and the book says melting point, but it's a range of 61 to 65 degrees. And so this cream would need to be formed at roughly 65 degrees, where you heat the water phase to 65 degrees, so that the oil phase would be 61 to 65 degrees. When you merge the two, they blend nicely together. So you need a thermometer whenever you're making your creams using the fusion method. The phases are merged and they are mixed, continuous mixing, until you reach ambient temperature, which is a temperature in your surrounding environment, and the nice fluffy cream forms or the mixture congeals. Mixing is continuous until the cooling takes place, because you don't want to stop mixing and the oil phase separate from the water phase. Remember, you need the mixing for an emulsion to form. Once you have uniformity and you see that congealing taking place, then you can stop mixing. And importantly, traditionally, the water phase is what we would heat and add to the lipid or oil phase that would have been melted and also at the same temperature. But in my reading, either way, the cream will be formed. Now, in making a cream, modern technology, we do have handheld high shear mixers. These are blenders that you can find online. For example, I took this one from Amazon. These high shear blenders offer mixing and the benefit of using things like these. You do have mini ones that you can actually have in your labs. You have reduced particle size. The oil droplets and globules are really micronized or made small. And so this improves the stability of your cream so that the water phase does not separate from the oil phase, which is called cracking in an emulsion. You may also have creaming and flocculation taking place in an emulsion where you have separation of the phases, but not total separation to the point of being spoiled. So these are little gadgets that you can have in your lab if you want to make creams. Now, if you like this content and others like these on this channel, it takes a lot of time and energy to put content together. Remember to like and subscribe for more content like these. Thank you for watching part 2 video. In the next video coming up in the series, we are actually going to look at some formulations and how we would make them.